Okay, this is going to be, I think, a series of, well, at least two more detailed videos on how to make moonshine, at least how I do it and the equipment that I've got. So, to start with, you got to ferment something. All right, well, I'm cheap. I didn't want to buy commercial stuff. I think it's too spendy for what you get, but it's easier. I can't knock it for that. This needs to be cleaned a little better on the outside. But anyway, what have I got? I got a cheap from eBay 80 quart stock pot. Okay. I measured the diameter. Well, I think it told you the diameter was 18 inches at the top and 19 inches deep. Okay. Comes with a lid with a convenient hole in it, and I can use that to drop a long thermometer into and read my temperature of my water as long as I get it up to where it's at the depth I need. All right, well, my fermenter is actually a beer keg. I cut a large hole in the top. I'll go into that when it's time to fill it. I'm just going in order. So anyway, first thing you gotta do is heat up the water, and you gotta add your grain and whatnot. So back onto this stock pot. I got this weldless stainless steel ball valve bulkhead fitting. It took some goofy special parts to figure out exactly what I needed, because in the inside I bought a false bottom. I think that stainless steel false bottom that was, I think, 17 inches in diameter, whatever it was, I measured it and found one that would fit, and I got 100% silicone tubing that can handle the heat and stainless steel hose clamps. That's a goofy fitting on the end of that ball valve that the inside was threaded also. So I could have a barb fitting on the inside of the weldless bulkhead fitting, and there's silicone washers that seal that to the side. And then the only tricky part of that, a lot of tricky things I'm always claiming. Anyway, you need a step bit like that. Stainless steel doesn't like to drill with normal consumer grade drill bits, but if you get one of those step drills, they've got them in Harbor Freight. As long as you get the first hole, it could be kind of ugly. Then if you're careful and slow, you can get a clean hole drilled of the diameter that you need to install a fitting like that. And then you can always take it apart, because the silicone washers, you just tighten it to where they're kind of squished, but they're not totally busted off. You can always loosen that off and take it out and clean it if you need to. So anyway, 80 quart stock pot. Later, I'll talk about, for the still operation, I got this fella, which is gonna be under new construction because I have a better idea for this seal. This is that PTFE seal that I got because it's very chemically inert, so the alcohol vapor won't affect it. But because you don't have a ring, you have to make a seal. Needs cleaning badly, but you're gonna have a gap. So all the time I've been doing this, it does work, but I have had to put, just like the old scrollers do, a little dop of oatmeal, just ground up oats mixed with water to get a paste right there, and it works. Had to drill another hole for a temperature probe and another hole for a stainless steel fitting for the coil to come out, either to the doubler or straight to the worm. Those are special stainless steel fittings you can get on eBay. They're kind of spendy, annoyingly, but it makes it for a quick connect operation. So all I got to do is stick the copper pipe that has its own stainless steel fitting on the bottom, tighten the nut, and you've got the connections. So that's my setup. This is just a cheap stainless steel salad bowl, and when I looked it up on eBay, happened to fit the diameter on top of this. Pardon my camera work here. So that fits right on top of there, and you probably saw the pictures. There's a million wood clamps that are pretty powerful clamps. You just clamp them around these two stainless steel lips. They pinch that down tight. You gotta remember, this isn't holding in much pressure, because you're not boiling water to get steam vapor. In fact, you'll see in a minute, the electric heaters I have really can't even heat water up to boiling temperature. which I kind of like for that reason. No open flame, and they really can't overheat it. So, like I said, this is the first step of just getting the grain in there in the hot water. So I got to get it heated. Well, how do I do that? Showed you how I made the pot. The lid, like I said, it's got a hole for temperature probe. So I fill it up to water till that temperature probe can get in there. Keeping in mind, you're going to lose some water that gets soaked up in the grain you can't get out. I'm going to try this batch fermenting on the grain. But the reason the false bottom is in there and you fool with that, it just lays in there, by the way. It's loose. So you can pull it out to clean it. But the point is, if you put cracked corn in there, and then you heat the water up, then you put the cracked corn in it, you let it soak, and as the temperature drops down, the amylase is an enzyme that does its work to convert the starch into sugar, and then the yeast can do its job later. But you get it that far along, get it below 150 degrees, and all that work has been done by the enzyme. Now you're ready to drain it off and put it in the fermenter, which I said is the stainless steel keg I have. Well, the devil is in the details. You got a bunch of grain. Well, you can use a racking cane with a high temperature racking cane or whatever, but it clogs up. There's various ways to get around this, but the way I think is easiest is what I got with that false bottom. So I put another silicone hose right from here that goes down into the stainless steel keg fermenter that you've already got clean and sterilized, ready to go. When you open this ball valve, all the liquid drains out and all the cracked corn and other grains get trapped on top of that false bottom. So your liquid comes out, you don't clog up the works. Now I said for this batch I'm gonna ferment on the grain, so I'll drain that liquid off just like I described first, but then I'll reach in there and scoop it out and go ahead and put the grain in the fermenter also. So this is a sloppier procedure than I had normally done, where I just rack off that, well, use the false bottom and drain off all that liquid. That goes into the fermenter. Then I'll add cold water to get it up to the right volume, which is 15 gallons inside a 15-gallon keg. And then you can mix in the appropriate amount of sugar. You're ready to go. Once it reaches temperature, you're all set, and you can throw in the yeast and seal everything up. I'll get to that later, but a lot of jargon. That's my basic setup for getting the, I think it's called a wort at that point, ready to go, or the mash. I forget the correct terminology for exactly where we're at, but the gist of it is you heat up water in a vessel like this, you get it above 165 degrees, you put the appropriate amount of grain in there for the batch you're doing, you let it soak in the water and you stir it up regularly, and you take it off the heat at that point. So as the heat reduces, the enzyme does its work, makes all those starches turn into sugars, then you drain off the liquid and you're ready to ferment it. Same process for beer or any other form of fermenting. You have to do some process like this to get the sugar out of the fruit or the grain or whatever you're doing and ready for the yeast to do its work. This is the cheapest way I could figure out to get 15 gallons in a fermenter at once without buying commercial stuff. I mean, I think even these brew kettles are 300 something bucks by the time you get the right valves and whatnots on them. So, you know, I think the quart stock pot here, 80 quart pot, was probably, I think, like 80 bucks delivered. The salad bowl might have been 20, something like that. The stainless steel ball valve's not that cheap, but they're readily available. That special fitting, if you want to do a false bottom, again, you got to pay attention to all these little bits and pieces, and I'm terrible with remembering the right appropriate sizes for national pipe thread or NPT fittings. But anywho, you figure it out. Either buy something that you can use, or you can make something like I did, like this. Next thing you got to do is get that water heated, right? Well, you can't put 8 pounds per gallon, 15 gallons in there. That's a lot of weight. I use cheap little Walmart single burner hot plates because they can't really get too hot. It takes forever to heat the water up. I can live with that, but it can't take the weight. So you'll see what I do here in a second. So here's the setup, ugly as it is. You can tell this is making contact at the bottom of that pot. That's what you want. It'll make better contact when you get the weight in it of all the water. Right now it's empty. This one's pressed against the bottom. Like I said, that's the arrangement. It's close enough to the edge that you can drain off. Put a high temp silicone hose on here. It will drain into the fermenter. And also, I put this on 2 different cords so that you can have 2 different circuits that operate these. I think they're 1700 watt is what the burners are, but I run them to 2 different household 15 amp circuits to make sure I don't blow the breaker. And they do make the little cheap timers that can handle, I think, 1875 watts. So this takes a long time to heat the water up. So if you want to, which I have done, you can set the thing to come on, fill it up with cold water, and then set the thing to come on at, 2 hours before you're going to get up. At worst, you blow a breaker or something and you find out your water's not hot. But you can't burn the house down this way. Well, I guess you could figure out a way to burn the house down or burn your building down, but it works for me. It's after I said that, it is always good to watch it. I actually rig up a wireless camera so I can, anytime I want, check what this is doing from where else I'm sitting or where I'm at. Anyway, blah, blah, blah. Point is, there's 2 burners. It's a cheap way to make it work, but it's plenty of heat to get this up to temperature with no open flames, which I like. That's my setup. One more thing. I have said before, the devil's in the details. Well, you got to be able to fill this up with water and drain it out. So my workbench is on wheels, which is what this is sitting on, and it can handle the weight of that thing full of water. And then I can wheel it over to a sink over here, and I can get my water out of the tap because this pulls out and can reach way up over the top to fill it. Little stuff like that is a real pain in the butt if you don't have a system to do it, and you got to figure out, oh my God, how am I gonna, you don't have a drain, for example. How am I gonna move all that weight of liquid water, especially if it's hot, around? You gotta be careful. You gotta figure out a system. I'm just showing you mine. I'm sure there's better ways, and I'm always trying to think of more efficient, easier ways to do stuff, but right now, I don't have to lift anything. In the past, I don't remember why, hooked up ropes to this or chain and used a chain hoist on my beam in the ceiling in order to lift that pot full, and then I could roll the workbench out from under it and lower it to the ground. So anyway, you have to just figure out these little things, but my method is gonna be wheel the workbench over to the sink, fill this up with water, get it over there plugged in 2 different circuits, and let it start heating, and then we'll add the grain. So we're just starting out, we're sitting at 100 and, I don't know, what does that say? 130 degrees? I can't read it from this angle, phone's held up way. Anyway, that's where we're starting at. Crank the temperature probe over there where it's easy to walk around the bench and read it. There's burner number 1. Crank it on. Same thing with burner number 2. Get over there. There you go. Keep an eye on it when it gets above 170 degrees, something like that. We'll add the grain. So for this particular recipe, it's going to be all corn, and I have some amylase because I don't have any malted corn. So from the brew store, you can buy amylase, which breaks the starch down to sugar. It naturally occurs in malted grain. Malted grain means grain that you let sprout, and then you stop it after it sprouts a little bit, dry it up, break all the shoots off, and that's malted grain. The enzyme has been released, and it doesn't take much. So if you put 20% malted barley, for example, into your moonshine mash, then that's enough of the enzyme to break down all the rest of the 80% corn that you put in there. Well, I don't have any malted barley, so amylase is the enzyme that does it. I just bought for this particular case, which I hate doing things this way because I like to do the au naturel way. But anywho, I have malted it from scratch before. I let corn sprout in the basement. It's a pain in the butt. There's a whole bunch of it takes babysitting to keep mold from growing in it, but you can sprout it over the course of a week and then dry it up, and there's your malted corn or barley or whatever. I'm not doing it that way, but for this recipe, I'm doing 100% corn, and it calls for 21 pounds of cracked corn and about 24 pounds of sugar is the way I'm going to do it. And it should get, using distiller's yeast, 15 to 17% alcohol by volume ish. So that's what we're going to do. You can get these at Harbor Freight too, up to 70 pounds. So it makes it easy. This is a lightweight stainless pot. You can put that on there and zero it out. One of these things makes your life easy for measuring quantities for homebrew. Sometimes when you get your feed from the store, if you get your corn from the feed store, it's not human grade ready for pantry. It's cheaper, but you do got to go through it and get all the corn stalks and maybe cockburrs and nonsense out of it. Give it just a quick cleaning before you put it in. Okay, we've been down there about an hour. It's plenty hot. That's what 21 pounds of grain looks like. That's not a 5-gallon pot. I don't know how big it is, but more than you would think. So anyway, on my rig, the only thing you gotta remember is stainless steel spoon. I'm gonna dump it in there and stir. And you gotta be careful not to get involved in that silicone hose and get caught on that and pull it loose. It's hose clamp, but the hose is very soft, so you don't really tighten it up. Just enough to keep it from, what am I trying to say? You can manage to pull it off if you were down there reefing on it with a spoon. So stir and take it easy. Don't stir right in this area where the silicone hose is. Other than that, one last thing. While you're doing that, and while you're waiting to put the grain in there and it's heating up, that's your time to come over here and sterilize everything. This is the kind of product you need, one like this, where it's a one-step sanitizer. It takes, I don't know what it says, something like tablespoon per gallon, whatever it says, but anywho, I put that, anything that's gonna touch the liquid, once it drains out of that heating vessel over there, anything that's gonna touch it should be sterilized. That means the airlock, the hose is gonna be used to drain it from here into from there into this, which is gonna be the fermenter. So there's liquid in there, put the Star San. I rolled this keg around so that the liquid touched all the surfaces a number of times. You gotta let it sit for at least 10 minutes. Same thing with this surface. There's a silicone ring that goes on this. Anywho, I'll do another video segment on the actual fermenter equipment here, this keg and how it was set up. But I'm just saying, remember to sterilize your stuff. Anything that's gonna touch the liquid after this point should be sterilized. There's what it looks like with the corn stirred in. Put the lid back on it. Put your probe back in. Boop. And you got to come down here and stir this every once in a while. But anyway, that'll get back up there to 165 or so where it needs to be. Trust me, I know from this system that's what it does. So anyway, you just keep stirring it until it gets about to 148, somewhere beneath 150 a little bit. Then you're ready to drain off the liquid into your fermenter. I forgot to mention, probably, at this point you turn off the heat. So these are both off now, and you just let it sit there and do its thing. There you are. And you're just waiting for the starches to get soft, the amylase to break things down, which actually it's not in there yet. So this doesn't have any malt added. So right now you're just kind of softening the starch and leaching it out of the grain with the hot water. We'll add the amylase when it gets to 148 degrees or whatever. Then you let that sit for 60 minutes and keep stirring it. And you'll notice it'll go from oatmeal type consistency, real thick. As that starch breaks down to sugar, it'll get real liquidy again, like water with, hard corn grains in it. So you can notice it, but that's the process. Okay. We're not ready yet. This is still letting the amylase work, but I wanted to show the next phase here. There's more than one way to skin the cat. I used to just drain the liquid from there directly into the keg, which is the fermenter. And then you had to add water, and I'd add cold water. And you still had to wait for it to be at a temperature where yeast can be pitched. So I decided that I had this from my beer brewing days. I made it, and I haven't used it since. It's a counterflow work chiller, homemade. So for those of you that don't know, what that means is there's a little tube within a big tube. So I went to the hardware store and got the two different sizes and all the appropriate fittings. It's kind of a bugger to get lined up and soldered, but it can be done. So what happens is, this is cold water in just from a spigot connected to the house. That goes down and flows around, and there's a tube in the inside, right? So it's just water flowing through the jacket. It goes up the coil and out here and then to a drain. You don't have to run it full blast, just have some water going through there, cold water. And then gravity feed from here through here goes through the inside tube, and there's a ton of copper surface area that cold water touches, so all the heat gets transferred out to the other water that goes down the drain. And then finally, see, this is not normally connected together when you're ready to drain it. This is the output. I have a sanitizer solution in there right now. So when that gets cooled down to temperature, we'll hook this silicone line up to the nozzle, the ball valve. Then we'll turn on the water flow. This line will drain directly into the fermenter, and that's where we're gonna pour off our liquid. When it comes out, it should be 75 degrees, something like that. So it's gonna drop it from about 140 to 75 degrees or so. Maybe it'll be more than that, I don't know. But I know it'll be well below the 90 that you want it to be to pitch yeast. So that's what that thing is. They're not hard to build either. I think I took a CO2 tank from a keg system and used that as a round thing to roll it around. I slid the narrow piece of tubing into the bigger piece of tubing, and then went ahead and pressed it against the concrete floor and just started rolling that CO2 tank to make the bends without kinking it until I had, I don't know what's there, 6 coils or something like that. Then you have to slip these little fittings on and get everything, fluxed. And you can use a propane torch and lead-free solder to get it done. And these T-fittings go to garden hose fittings on both ends. So once you connect these two, this piece is easy to move and store and whatnot. Anyway, like I said, I'm always trying to make things more efficient. That's what that thing's gonna do, is allow me, when I'm ready, to transfer very hot liquid, and it comes out the other end ready for yeast at a much cooler temperature. So if you get some magic stuff called tincture of iodine, and you take a little sampling of your batch, don't get any kernels in it or anything, but just a little sample batch here. And this is poison, so you don't put this back into the batch. But so if you get this magic chemical, tincture of iodine, it turns blue in the presence of starch. So that tells you, see blue like that, it's not done. That means you're supposed to stir it and let it keep going. Let's see. Oh, nice and brown. No blue. Winner. Finally ready. We're down to temperature. Iodine test is good. I'm gonna use the old false bottom and strain just the liquid off. I might have said I was gonna do it on the grain. I'm not gonna do it. Pardon me. But this is the system. You can see it. So the water, cold water, is going to go down to the bottom and spiral up the top and go through the drain. And the good stuff comes through here and out into there. I've already put 21 pounds of sugar in there. So as it gets to get enough liquid to stir it, we'll be stirring that up. But this should ensure that's the right temperature before we get ready to throw the yeast in there. So this is the cold water to go through the jacket. I'm gonna go 2 bananas with it. Probably enough. And turn on the good stuff. And there it comes. Yeah. Going in there at, I don't know, 80 degrees, whatever that says. Not bad considering it's sitting in the pot at 135. So that's the purpose of the counterflow chiller. I'll let that drain all the way in there, stir everything up, and then I'll show you I'm going to seal the vessel up for fermentation and pitch the yeast. Still going. You get the idea though. All the grain's going to get caught, trapped in there, and then easy to clean out. And the clean stuff is still coming out the end of the hose. All the sugar's been dissolved and stirred up, and usually the grain sucks up some amount of the water that you started with, so often you got to add in water, cold water to just top it off and be ready to pitch the yeast, but that's just about it. I mentioned you're gonna have to add water. That's true. You can see where it's getting. But anyways, you can also wash the grain off again because it just drained, but you can take some fresh, clean water and dump it over your grains again to give it a final wash and add your extra water that way, and get some more of those sugars out of there ready for the yeast. This is just aerating the yeast and topping off the system. Yeast time. Oh, did you stir it?
Yes.
My helper may not have stirred it.
I stirred it.
Whoop. Okay. One final stir. And then, we're done with that. Here's the gizmo. Food grade neoprene seal. Gonna go on here. If I can do it one-handed. Totally can't. That. The idea, by the way, is, you're not boiling this mixture to where you can remove everything that's in there, bacteria and natural yeast. The idea is that this yeast will totally overwhelm all the other bugs that might be in there because you've done your best to eliminate the other ones. That's going to overwhelm it. It's going to make CO2 in there. Lots of other things can't survive with no oxygen, and all there will be is CO2 yeast farts in a minute. This is going to go on here like that. Then we got this fella right here. But these things hook in the keg handle, sits over there and squeezes down that seal to ensure that it's tight. Then here's your 3-part airlock. There's a rubber bung. It's gonna go right here in the middle. And then tomorrow it'll be bubbling. That's it. After about 12 hours, it should be doing that. Whoop. I just thought I'd make another quick comment on this system. I mean, it's mostly driven by my cheapness, why I made this fermenter the way it is. And partly it was inherited from somebody else. Somebody gave me a reflux still that had the opening cut in the original keg that I had, and has an ice bucket like that that's stainless, that has a bracket on top, and the whole reflux still mounts on the top. Okay, fine. So I modified that to be a fermenter, so I didn't come up with the idea, but what's the point? Point is, lots of the commercially made stuff might have I think they're called tri-clamps. They look great, they're easy to use, and they got a silicone seal, so it's just, you know, real easy and nice to keep clean. But I mean, for this system, just for the fermenter, I mean, I got a 10-inch hole to be able to reach in to clean. Those tri-clamps, I think you get about a 4-inch hole. And the still that I've got set up where well, that'll be a future video, but where I mentioned it's the 80-quart stock pot and then a stainless steel salad bowl on the top. Well, the advantage there is when you take the top off, you have the full 18 inches to get in there. There's no sharp edges, it's just the top of the stock pot with that rolled, you know, metal. So easy to clean when you take it apart. I got high hopes that there's a food grade silicone gasket like that on order that's coming, that's supposed to be 18 inches in diameter. If that works out, then that will solve the same problem of getting rid of that PTFE seal that I made before. There's not a gap that you have to seal with oatmeal or something else. It'll just be clamped together, you know, like the tri-clamps are, but like I said, I'll have an 18-inch hole for it being able to get in there and clean everything. It's simple. It's also kind of nice. You flip the salad bowl upside down and it sits right inside the stock pot, hangs on the lip, and then you can put the lid back on it, so when you're just storing it, you keep dust out of it, and it's all, you know, kind of like those stacking dolls from Russia. Anyway, just wanted to mention that when you're thinking about this stuff, you know, you got to think about how easy it's going to be to clean it. Usually for fermenting and distilling like what I'm doing, you don't make a big mess, but I know I had fermented homebrew beer before, and wine, cider, perry, a bunch of different things, and sometimes the yeast gets more sticky in there. There's more drub or whatever they call it, to clean out, and it actually requires scrubbing with a brush for some of that. Usually just the corn-based mash does not, in my opinion, at least usually doesn't. But well, with a 4-inch hole, that could be a problem. Trying to reach in there and get around the corner to scrub, because when I have found dried up yeast, it's right underneath on the curved part, you know, where the top of the liquid sits, is where it kind of sticks on there, and maybe it dries a little bit, and that would be kind of a bugger to reach through a 4-inch hole and then trying to go 4 inches sideways to clean it. Just saying. All right.